What's up, everyone, and welcome to this in-depth lesson on graphing linear inequalities. Now, at this point, we already have a whole collection of algebra skills that we're going to apply to this new concept. So let's just start off with solving a simple equation. In this case, x plus 5 is equal to 8, which we know has a solution of x equals 3, since 3 plus 5 is equal to 8. Now, if we think of the solution to this simple equation in terms of a number line, we know that 3 is the only possible solution, and that any other value would not work for x since there's no other number that you could add 5 to that would equal 8. So this simple linear equation only has one possible solution. However, what if instead of an equal sign, this was an inequality? So now we have x plus 5 is greater than or equal to 8. If we were to solve this, our solution would be that x is greater than or equal to 3, which means that x can be 3 or any value that's larger than 3. So now our solution includes the number 3, so we're going to use a closed circle since it's greater than or equal to, and anything that's greater than 3, so you have to shade to the right. So we can say that 3 is a solution, and any value that is larger than 3 is a solution. And we can also say that any value that is less than 3 is not a solution. And since we know that there are an infinite amount of numbers that are larger than 3, we can say that the solution to an inequality is a set of an infinite number of solutions. Now, before we move on, let's imagine that that inequality sign was a greater than symbol instead of a greater than or equal to symbol. In this case, our new solution would be x is greater than 3, which means that 3 is no longer included, so our circle is not shaded anymore, and now we can say that our solution set is any value that's larger than 3, but not including 3. So now that we've refreshed all our prior knowledge of equations and inequalities, let's ask ourselves, what are inequalities going to look like on the coordinate plane? Now we already know that in linear equations, such as y equals x or y equals negative x, that any point on the line is going to be a solution to those equations. But we're interested in inequalities here. So if these were inequalities instead of equations, they would look a lot different. If we had y is greater than or equal to x, we would have to shade all the area above the line. And if we had y is less than or equal to negative x, we would have to shade all the area below the line. Now this shading is dependent on the inequality sign. When we have a greater than or equal sign, we are going to shade above the line. And when we have a less than or equal sign, we are going to shade below the line. So maybe now your mind is blown and you're asking, what does this mean? We already established that when it's an equation, all of the points on the line are solutions. Now with inequalities, not only those points on the line are solutions, but the points in the shaded area are all solutions as well. And later on in this lesson, we'll explore why. Now, this is the case when we have the greater than or equal to or less than or equal to symbol. If we were to replace those inequality symbols with just greater than or less than, like we're going to do right now, this changes things a little bit because now the points on the line are no longer included in the solution, and only the points in the shaded area are. So in these cases, we'll be using a dashed line to indicate that the points on the line are not included in the solution. So if you're seeing this for the first time, it might be a little confusing. So before we get into any examples, let's just try to clarify here. If we had the inequality x is greater than or equal to 2, we could say that the solution is any value greater than or equal to 2. So any number larger than 2 and including 2. However, if it was just a greater than symbol, x is greater than 2, our solution would be any value greater than 2, but would not include 2. So when graphing these linear inequalities, the greater than or equal to or less than or equal to symbols have a solid line where the points on the line are included in the solution, and the greater than or less than symbols have a dashed line where the points on the line are not included in the solution. So now we are ready to check out our first example, and we'll consider the linear inequality y is greater than or equal to 3x minus 2. We can graph this just like a linear equation by starting at the y-intercept -2 and using the slope to build the line. And since our symbol is greater than or equal to, our line is going to be solid. That greater than or equal to symbol also means that we have to shade above the line. So the entire region above the line is going to get shaded in. So now we have the completed graph of this linear inequality, and now we can go ahead and choose points to see whether or not they would be a solution. So let's start by checking a point in the shaded region. So we're going to choose the point with coordinates -5, 5. Now those are x, y coordinates, so we can replace those two values, the x value with -5 and the y value with +5. And now we just have to evaluate. So 3 times -5 equals -15, and -15 minus 2 equals -17. So we're left with 5 is greater than or equal to -17, which is true, and should help us to understand why any point in the shaded region will be a solution to this linear inequality. Next, we'll look at a point that is on the line. In this case, the point with coordinates 2, 4. So again, we're just going to replace the x value with 2 and the y value with 4, and then we can evaluate. So we know that 3 times 2 just equals 6, and 6 minus 2 equals 4. And what we are left with here is 4 is greater than or equal to 4, which we know is true. And this should help us to understand why any point on the line is also included in the solution set. Now finally, what about a point that's in the non-shaded region? Let's choose the point with coordinates 6, 0. So again, we'll replace the x value with 6, the value of our x coordinate, and the y value with 0, the value of our y coordinate for this particular point in the non-shaded region. Now 3 times 6 is equal to 18, and 18 minus 2 is equal to 16. So now we're left with 0 is greater than or equal to 16. That, of course, is not true, and this should help us to understand why points in the non-shaded region are not included in the solution. So to recap, any point in the shaded region or on the line is a solution, and any point in the non-shaded region is not. So now we're going to look at one more example. In this case, we'll be examining the linear inequality y is less than -1/2 x plus 4. So again, we're going to graph this line, and since it's a less than symbol, we're going to use a dashed line instead of a solid line. And less than means that we need to shade the region below the line. So now we're ready to check out some points, and we'll start again in the shaded region, and let's use the origin 0, 0. It's a really easy point to use. So again, that's an xy coordinate, so I just have to replace the x value with 0, and also the y value with 0, because it's the same value for both x and y. And then I can just evaluate. -1/2 times 0 is just 0, and 0 plus 4 is equal to 4. So we're left with 0 is less than 4, which we know is true, and this should help us understand again why any point in the shaded region will be a solution to this linear inequality. Next, we'll look at a point that is on the line, and let's choose the point 0, 4. Okay, so now again we want to replace the x value with 0, and replace the y value with 4, and then just evaluate, and then we can check and see if it's true or not. So again, -1/2 times 0 is just 0, and 0 plus 4 just equals 4. Now we're left with 4 is less than 4. That is not true. So this should help us to understand why when we have a dashed line, that the points on the line are not included in the solution set. And finally, let's see why a point in the non-shaded region will not be a solution. So let's go with the point 6, 8. So again, replace the x value with 6 and the y value with 8 and evaluate. So -1/2 times 6 is equal to -3, and -3 plus 4 is equal to +1, leaving us with 8 is less than 1, which we know is not true, and this should help us understand why any point in the non-shaded region is not a solution. So now we can better understand why that when we have a dashed line, only the points in the shaded region are in the solution set, and all of the points on the line and in the non-shaded region are not. And that is it for this lesson. We finished another one. Thanks again for stopping by. See ya. Thank you again, everyone, for joining us, and please reach out to us on Twitter at MashupMath. We are dying to hear from you, so please share some love. All right, we're done here.